or good evening, whatever time you are, watching this video, this educational video about the two types of error that we discussed in our previous video. So when we say systematic error, don't forget that it will affect the accuracy because in the very first place, the method is wrong and it generates a one direction result. And of course, that will gonna be away from the true value. So it affects accuracy. Meanwhile, a random error is a type of error that affects precision because a random error is due to uncontrollable events like the change in weather during the experimentation or gathering of the data. And you're using a less precise or imprecise instrument while doing the experiment, or there are a lot of people in the group viewing or observing the calibration of the substance or the materials or the matter that you are measuring. Okay, so we all know that in order for you to lessen the random error, you have to repeat the trials from time to time, or I mean, you have to do repeating trials and get the average. And you have to use the precise instrument. On the other hand, systematic error will be lessened if you will improve your method, your design, and you will calibrate equipment to zero before you will continue or start the experiment and improve your measuring technique. Okay, so let's have a practice here. These are samples of statement, and then we will be judging if ever it's a random error or a systematic error, or it has, or it suggests a random or systematic error. First one, a thermometer consistently reads 2 degree Celsius higher than the actual temperature. So what type of error is this? So it's consistent, very consistent. It's not random. So therefore, the answer for this one, it generates a 2 degrees Celsius higher than the actual temperature. It's not the accepted value, and it's consistently reads 2 degrees Celsius higher. So that's gonna be a systematic error. Okay, I'm very sorry for my handwriting. Systematic error. Okay. And the second one, a student measures the length of a table multiple times, many times, and gets slightly different results. So maybe the results are like closer, but not the same, right? In 5 times. And yeah, and the reason why it has a slightly different results, it's due to the hand movement. So what type of error is this? Obviously, it doesn't give you the same results, right? And at the same time, it has a random or slightly different results, and it's due to uncontrollable situation of a hand of the person or the student who measures the length of the table. So it is obviously random. Yeah, it suggests random errors. Okay, thank you. And we have another sample here. A scale is miscalibrated to read 1 kilogram heavier than the actual mass. If you weigh 10 objects, what type of error will this introduce? So it's miscalibrated. It does not change. It does not calibrate it to zero before weighing these 10 objects. So it will suggest same consistent result, but then again, it's a it suggests a systematic error. SE. You miscalibrated, and then it read 1 kilogram heavier than the actual true value or the accepted value. And then next, a student records the time for a pendulum to complete one swing, or the period, right? The period when a pendulum will have one complete swing. And then the result varies slightly due to air currents. Air currents is our North Star here. We cannot control the air currents. And then the type of error, is, of course, a random error. R. Thank you. And now it's a quiz, and I want you to uh, answer. You can pause this video for some time to, judge or to select the best option. Okay. So a researcher notices that all temperature readings from a thermometer are consistently 2 degrees Celsius higher than they expected. What type of error is this and how can it be corrected? So it consistently give us a 2 degrees Celsius higher than what we expected. So yeah, it's consistent, and what particular error, and then how can it be corrected? Okay, so let's reveal the answer. This is not, of course, letter D is not anymore the correct answer because environmental error is not, you know, it's not part of the two types of errors. And when we talk about uncertainty of measurement, systematic error, yeah, it's consistent. And then if you want to correct this method, you can recalibrate the instrument. So I guess it's the perfect answer, right? Human error and then replace the observer. It's not the answer. Random error, it results consistently, it resulted to a consistent data. So it's not random in the first place. So it's going to be not the answer. The answer for this item is letter C. Okay. Number two, a scale consistently reads 2 kilogram higher than the actual mass. How can this error be corrected? So it consistently reads 2 kilograms higher than the actual mass. It's a systematic error. How are we going to eliminate or correct this error? Take multiple measurements and average them. It's a way to reduce random errors, so it's not the correct answer. Recalibrate the scale, of course, based in connection with number one. It generates 2 degrees Celsius, I guess, consistently from the actual value. So it's good to recalibrate the scale. This is a good this is a good option. Use more precise instrument. This will really for the random errors, and then increase the sample size. It's really for the random error. So our answer is letter B, recalibrate, not to use a more precise instrument, but since it gives you consistent result, all you have to do is to recalibrate, and it will give you again a consistent result. Third, a student measures the height of a plant multiple times and gets slightly different results due to variation in lighting and condition. Lighting lighting condition. So this lighting condition is uncontrollable situation, uncontrollable events, inevitable, and then we have slightly different results, not consistent. So this is going to be a random error. Okay, I hope you can visualize now the difference because of these situations here. Number four, a clock runs 5 times fast every hour. How would this error affect the results of an experiment measuring time intervals? A clock runs 5 minutes fast every hour. So it will, of course, overestimate the time intervals because a clock runs 5 minutes fast every hour. So it will have a greater result. So it overestimate time intervals. This is the correct answer. Results would vary unpredictably, no, because the clock runs always 5 minutes fast every hour. Results would consistently underestimate. It will not underestimate, it will not lower the value, but instead it overestimate the value. Results would be unaffected. It is affected because this is a systematic error and systematic error affects accuracy. So the answer for this item is B. The fifth one, which of the following is not a characteristic of a random error? They are predictable. They are predictable. Uh-huh. Random error. We're talking about random error. Okay. Okay. They are predictable. No, we cannot predict the weather. changes or the condition of our hands or the angle from our observation. So this is a hold on. Which of the following is not a characteristic of random error? They are predictable. We cannot predict the weather. So this characteristic of a systematic error, not random error. They can be reduced by averaging multiple measurements. Yeah, this is one of the definitions of random error. They generate scattered measurement in repeatedly. Yeah, scattered, not the same. They are caused by uncontrollable factor like environment and environmental noise. Yeah. So the answer, which is not a characteristic of a random error. So this is not a characteristic of a random error. So letter A is our answer. Thank you so much, and I hope this set of these examples might help you in determining if it has random or systematic error. I hope you like this video, and I hope you will give a thumbs up and subscribe if you like. See you around on the next video. Thank you so much. All right. Good morning. Good afternoon.